It's a wonder I can think at all.
Okay, onwards to Chapter 3. Section 3.1 is on velocity. So reminder, the instantaneous velocity of an object is defined as the limit of the average velocity over an ever-shortening time interval. So that's something we looked at near the start of the course when I drew the drawing of the car, and we said if you wanted to know the instantaneous velocity, you could have the two people standing apart from each other, and you could calculate the time it takes for the car to go from here to here, and the distance there is between those two people, and you could get the average velocity. And as one of the people moved closer and closer and closer to the other person, you'd be getting closer velocity to the actual instantaneous velocity. How close do you want to get them? You want to get them to as close as possible, but they can't actually be right on top of each other because you wouldn't be able to get the velocity in that case. Okay, anyway, if the position function is s equals f of t, so in other words you have a function that expresses the position of some object, where s is the displacement of the object from the origin at time t, then v, the velocity, equals s prime. In other words, the velocity is equal to the derivative of s. The other way you could say that, since s is f of t, we could say it's equal to f prime of t, because that's the derivative of f of t. The other way you could say it, if you want to go all the way back to the start of the course, you could say it's equal to the limit of f of t plus h minus f of t divided by h as h approaches 0. So here you have our difference quotient from right at the start of the year. Remember, that is a derivative. And all the things we did last time with the power rule, last chapter with the power rule, and the sum rule, the chain rule, those are just faster ways of calculating the same amount as the difference quotient. Okay, in other words, what we can say is velocity is the derivative of the position function. If you have a function that tells you the position of an object, you can get the velocity of that object by taking the derivative. So we've got a bunch of questions to do, and we'll be done pretty quick today, I think. So a stone is dropped from a cliff. It's 175 meters high, and its height in meters after t seconds is h equals 175 minus 4.9 t squared. So this is your position function. What we want to do is we want to find the velocity after 1 and 2 seconds. So remember, if we know the position, the way we get the velocity is we take the derivative h prime. So let's get the derivative of this. Well, that's not very hard, because the derivative of a constant is 0, and then we just use the power rule here. The 2 comes down. You get negative 2, I might as well write it, negative 2 times the 4.9 t, and that 2 becomes a 1. So in other words, negative 2 times 4.9 is negative 9.8 t is your answer. So that's now works for any time. If we want to know 1 second, plug 1 in here. If you want to know 2 seconds, plug 2 in here. If you want to know 2.78, put 2.78 in there. What we want to know is 1 and 2. So let's plug 1 into this. Negative 9.8 times 1 is negative 9.8. Negative 9.8 what? Meters per second. And if we put 2 in there, negative 9.8 times 2 is negative 19.6 meters per second. So here's our two answers. My cat's banging at the door to get in, so excuse me for a second. When will the stone hit the ground? Well, this is more a pre-calculus question than a calculus question. If we want to know when the stone will hit the ground, what we're interested in is when h, the height, is 0. Now my cat's destroying my chair. Stop it. Okay, so 0 is the height. That's when it'll hit the ground, when this is 0. So 0 equals 175 minus 4.9 t squared, and we just solve that. So let's move the 4.9, the negative 4.9 over. You get 4.9 t squared equals 175. Divide both sides by 4.9, and you'll get t squared is 35.7. And to get t, you take the square root of 35.7. Remember, you're solving by taking a square root, so you need to put plus or minus, and you end up getting plus or minus 5.98. So we have two answers here, positive 5.98 and negative 5.98. But wait a minute, this is a real world question. This isn't just, abstract math question. This is a real world question. We're talking about time. When will the stone hit the ground? So the negative answer doesn't make any sense. It's only the positive one that makes sense. So our only answer is 5.98 seconds. Very close to 6 seconds. With what velocity will it hit the ground? So what we're interested in is when the stone hits the ground, which is going to happen after 5.98 seconds, how fast is it going? That's velocity. Velocity, we already found out that this function right here will always tell us the velocity. So all we have to do is put 5.98 right there. So let's do it. H prime of 5.98 equals negative 9.8 times 5.98. That equals negative 58.604 actually, but let's go with that. Negative 58.6 meters per second when it hits the ground. The position function of a cheetah moving across level ground in a straight line, chasing after prey, is given by the equation s of t equals t cubed minus 15t squared plus 63t, where t is measured in seconds and s is in meters. So this formula here basically will tell you where the cheetah is at a certain time. And what we want to know is what's the cheetah's velocity after 1 second and 4 seconds. We need velocity. Remember, velocity means take the derivative. So we got to find s prime t. Okay, so power rule 3 times here. Power rule here gives 3t squared. Power rule here gives negative 30t, and power rule here gives 63. Now we have to find s prime of 1 and s prime of 4. We love the 1 because you get 3 minus 30 plus 63. Negative 27 plus 63 is 36. So 36 meters per second after 1 second. After 4, a little bit harder. 4 squared is 16 times 3 is 48. Minus 30 times 4 is 120 plus 63. 112 is at negative 9 meters per second. What does this mean? Like one being positive and one being negative? All that basically means is it started at a certain point, and when it's going in this direction, it's positive. If it's moving back this direction, it's negative. So basically this cheetah is going like back and forth trying to get this prey, whatever the prey is, right? Okay, so we have our answers for this question. When is the cheetah momentarily stopped? Well, when something's stopped, the velocity equals 0. So in other words, s prime of t has to equal 0. Well, s prime of t is equal to 3t squared minus 30t plus 63. How are we going to solve that? Well, it's a quadratic, so we want to set it equal to 0, which it already is, and then we want to factor. So don't start doing Bobby Bridge here or whatever, because you can see you can factor out a 3 here. So take out a 3, you get t squared minus 10t plus 21. Why don't we divide both sides by 3 right now? Divide this by 3, it's gone. 3 divided by 3 is just 1. Divide this by 3, it's still 0, so that's great. So 0 equals, we're looking for two numbers that multiply to 21 and add to 10. Well, that's 7 and 3. So we have t minus 7 and t minus 3, which means our two times when the cheetah is momentarily stopped are t equals 7 and t equals 3. So now what we have to do is we have to find the positions of the cheetah at these two times, t equals 7 and t equals 3. So notice it's positions, it's not the velocity. You don't want to be plugging into this highlighted function here because this is velocity. You want to be plugging into this green highlighted one up there, which is actually the position. So let's do that. So what we have to do is s of, let's do 3 first, I guess, and s of 7. So if you plug 3, I'll show you what we're doing. We're doing 3 cubed, we're doing 15 times 3 squared, we're doing 63 times 3, 3 cubed is 27, 3 squared is 9 times 15 is 135, and 63 times 3 is 189. If you do that math, you will end up with 81 meters. I guess I should have put seconds up here, shouldn't I? Seconds, seconds. If you do the 7, you'd have 7 cubed minus 15 times 7 squared plus 63 times 7. And I tell you what, I don't want to figure out what that all equals. I know my final answer though. It equals 49. So 49 meters is your answer. Go ahead, I'm feeling lazy in this video. Go ahead and figure that all out, but that's what you'll get is 49 meters. Okay, D, when's the cheetah moving in the positive direction? When's it moving in the negative direction? Well, I guess it's moving in the positive direction when the velocity is positive, when the velocity is greater than 0. So the velocity is this yellow one, and what we want to know is when's that amount, that 3t squared minus 30t plus 63, when is that greater than 0? That's what we're trying to solve here. Remember how to solve quadratic inequalities? The way I do is I temporarily make it equal to 0 and I factor. Well, we already know that's going to equal. We did all that factoring up here and we got t minus 7 times t minus 3. So basically I'm going to factor all this side. I'm going to get 3 that you factor out, t minus 7 and t minus 3. And you don't need to worry about the 3 again because you can divide both sides by 3, which means our two answers are t equals 7 and t equals 3. Those are the ones where it's not moving at all. So then what you do is you take those numbers, and you put them on a mini number line, 3 and 7. And we're going to try some values in between these, right? Easy one to try, the best one probably, is 0. Let's try 0 down here. Where do you try it? You try it in the inequality up here. So if we put 0 in there, you end up getting 0 minus 0 plus 63 is greater than 0. Is that true? Yes, it is true. So we know that all of these work. Okay, what kind of dot should I be putting here, by the way? Should we put in an open circle because this is just greater than. Because this is quadratic, you know, it's like a parabola if you were to graph it, you know it's going to alternate. So you know this one's not going to work and this one is going to work, and it's going to go like that. If that's not clear to you, just pick another number in here, like maybe 5, and try it in here. 5 squared is 25, times 3 is 75, 30 times 5 is 150, 75 minus 150 is negative 75, plus 63, definitely negative, not greater than 0. And if you put 10 or something in here, you'll find it's positive. So here's our answers. These are when it's in the positive direction. Let's put down positive direction. Positive direction when what? When t is less than 3, but you shouldn't just say less than 3 because it doesn't, what's the smallest it can be? 0. It has to be at least as much as 0, right? So I would say positive direction when it's, I'm going to do it this way, from 0 to 3, not including 3, and from 7, not including 7, onwards. So what does that mean for the negative direction? Negative direction when, well, this time in between, those are all the negative directions. So that'd be from 3 to 7. Square brackets or circular? Circular brackets. 3 and 7 aren't included in the positive direction, and they're not included in the negative direction. Why not? Because 3 and 7 were when it's momentarily stopped. It's not moving at all, right? We got those values right down here, the 3 and the 7. So there you go. Of course, you could have written this in a different way. I don't really want to do it all, but for example, instead of this one, you could have said 0 is less than or equal to x, or t, I guess, for time, which is less than 3. That's a t. This would be t is greater than 3. It looks like I am going to do them all. And this one would be 3 is less than t, which is less than 7. So either the red or the blue works for your answer. Find the position of the cheetah after 10 seconds. Okay, position, we're just plugging into the original green one again. So we just need to find s of 10. S of 10 equals, well, it's going to be 10 cubed minus 15 times 10 squared plus 63 times 10, which means it's 1,000 minus, that's 100 times 15, 1,500 plus 630. And if you do that, minus 500, 130. And this is in meters. Last thing we need to do, find the total distance traveled by the cheetah during the first 10 seconds. Okay, this is a little bit confusing at first. So basically, we're going to say that the cheetah starts right here. We're going to call it t equals 0, times 0, right? And then what's going to happen is we've seen that it's traveling in the positive direction until time 3. So it's going to be moving in this direction, the positive direction, until time 3 right here. This is t equals 3. What it's going to do then is it's going to start moving. It's going to be momentarily stopped as it turns around, and it's going to be traveling back this way until t equals 7. Right? Negative direction until 7 seconds, 7 here for when it comes to rest again. Now we need positions for both of these. So we already have a position for time 3. We did that up here, right here. The position at time 3 was 81 meters. So we know that this is 81 meters. We also need to know, so this is seconds and this is 0 seconds, we need to know a position for time 0 here. Now you might be tempted just to put 0, and you might be right, but that won't always be the case. It's possible that the cheetah didn't start at the time that's designated 0. So we should actually figure out what's s of 0 before we make that decision. So if we plug 0 into the original green thing here, we get 0 minus 0 plus 0. I will write that down just so you see it wasn't just a matter of always putting 0 for the original position. So in this case it is, though. It is 0. So 0 meters. Okay, so that was when it's traveling in the positive direction until 3 seconds. It's momentarily stopped. Now it's moving back in the negative direction until it hits 7 seconds. Where is it at 7 seconds? We got that right here. It's at 49. So you want to come back roughly a little more than halfway, so probably around here. This would be at time equals 7 seconds. And we said at this point s equals 49. And then we're continuing on out until 10 seconds. That's what we want to know, first 10 seconds. And we said at 10 seconds, it's at 130 meters. So it's past 81, somewhere, I don't know, this is good enough. Let's just put it right there. This is when t equals 10 and 10 seconds. And our position is 130 meters. And what we want to know is, what's the total distance traveled by the cheetah? Okay, well, let's look at this in pieces. There's the time from 0 to 3 seconds. There's the time from 3 to 7 seconds. And there's the time from 7 to 10 seconds. Now the first one's easy. How far did it go from 0 to 3 seconds? It went from 0 to 81, which is 81 meters. How far did it go from time 3 seconds, which is right here, to time 7 seconds? Well, it was at 81 and then it went to 49. Now your distances are always going to be positive, so don't worry about having negative distances. What you have to know is, well, what's the difference between 81 and 49? So you could just go 81 minus 49 and get 32 meters. And similarly, to go from time 7, which was at 49, up to time 10, which is 130, we want to know the difference between 49 and 130. So you can go 130 minus 49, which equals 81. Last step, add those all together. The 81, the 32, and the 81. And if you add those up, 162, 164, you get 194 meters. In the first 10 seconds, the cheetah traveled 194 meters. That's pretty good, considering for human beings on a track for 100 meters, the world record's about 9.7 seconds, and this thing's going almost twice as far in approximately the same amount of time. Man, those cheetahs are fast. With that in mind, we will say goodbye to section 3.1 and to the cheetah.